Welcome to today's physics class, where we will talk about the continuation of our last class, which is speed, velocity, and acceleration. And today, we'll be talking about the equation of uniformly accelerated motion. And what is uniform acceleration? Acceleration of a body is uniform if its velocity changes by equal amount in equal time. In this, we are going to dive into the world of uniformly accelerated motion, explain its key equation, and learn how to solve problems using this equation. And suppose the velocity of a body increases steadily from initial velocity u to final velocity v in time t. The uniform acceleration will be given as a is equals to change in velocity over time taken. And from here, we can have that acceleration is equals to v minus u all over t. When you cross multiply, we have v minus u is equals to at. Move this minus u to the other side. We have v is equals to u plus at. This is our equation 1. And since the velocity increased steadily from u to v, the average velocity is the mean of the initial and final velocity. Let's say average velocity is the mean of the initial and final velocity. And we also know that average velocity is equals to displacement all over time. So that average velocity is also equals to displacement over time. When you equate this to this, we have u plus v over 2 is equals to s over t. When you cross multiply, we have, and make s the subject of the formula, we have s is equals to u plus v over 2 times t. This is our equation 2. But if we substitute equation 1, v is equals to u plus at, into equation 2, we have s is equals to u plus v will now become u plus at. This is u plus at all over 2 times t. And this plus this, we have s is equals to 2u plus at all over 2 times t. When you expand it, we now have s is equals to 2u times t. We have 2ut plus at times t. We have at squared all over 2. And this can also be written as 2ut over 2 plus at squared over 2. This cancels this. We have s is equals to ut plus half at squared. This is our equation 3. So let's resolve equation 4. From equation 1, which is v equals to u plus at, when you expand, which is from equation 1, which is v is equals to u plus at. Squaring both sides, that is squaring both sides, you now have v squared is equals to u plus at squared. This will now be v squared is equals to u squared plus 2u at plus at all squared. Open this bracket, becomes u squared plus 2u at plus a squared t squared. Removing the common a, we now have u squared plus a all over 2u t plus a t squared. From here, you can bring out the 2 from the bracket. Now becomes v squared is equals to u squared plus 2a bracket 2 divide this becomes ut plus 2 divide this, you have 1 all over 2 at squared. And from here, we can know that from equation 3, s is equals to ut plus half at squared, which is here. So impute s into this equation, now becomes v squared is equals to u squared plus 2as. This is our equation 4. So the fourth equation, starting from this equation of uniformly accelerated motion, will now be 1, which is v is equals to u plus at. We have s is equals to u plus v all over t times time. Third one, which is s is equals to ut plus half at squared, and the fourth one, which is v squared is equals to u squared plus 2as. The most important thing you need to know when using this 4 equations of motion, 3 parameters must be given, or let me just say 3 parameters will be given. So from this equation, you choose the one that will best suit the question that will be given to you. And secondly, for you to know these 4 equations offhand, you need to know the derivation of this equation of motion. When you know the derivation of this equation of motion, these 4 equations of motion will be easy for you to remember. From this equation also, we'll be using velocity time graph and this equation of motion to solve equation relating to this equation of uniformly accelerated motion. Let's go for question 1. Question 1. An aeroplane initially at rest, undergo a constant acceleration of 2.5 meters per second squared down the runway for 30 seconds before it lifts off. How far does it travel down the runway before taking off? From the question, the given parameter will be initially at rest. That means initial velocity is equals to 0. Undergo a constant acceleration. Acceleration, which is uniform acceleration, will now be 2.5 meters per second for 30 seconds. Time is equals to 30 seconds. And we are asked to find the distance traveled before taking off, which is S is equals to what we are looking for. So when you look at the four equations, let's say the four equations are this. 1 is equals to equation 1, V is equals to U plus AT. 2, S is equals to U plus V all over 2 times T. 3, S is equals to U T plus AT squared all over 2. And the final one, which is V squared, is equals to U squared plus 2AS. When you look at these four parameters now and compare it with these four equations, you know, and we are asked to find distance. From here now, we have three equations that has distance. But you will now look at the parameters on this equation to know the one to choose from these four equations. Since we have initial velocity, which is here, we have time, which is this time, we have acceleration, which is this acceleration, and we are asked to find t. So we can use this equation. Since the final velocity v squared is not given, so we can say that from that equation, S is equals to u t plus half a t squared. From here now, we can say that S is equals to U, which is given as 0, now be 0 times the time 30 plus 1 all over 2 times acceleration, which is 2.5, now have 2.5 times the time, which is 30 all squared. From here now, we can say that 0 times 30 becomes 0 plus 1 all over 2 times, we have 2.5, 30 squared will now be 900. 2 here, we have 1, 2 into 900, we have 450. So S will now be 2.5 times 450. If we are to multiply here, we have 1,125 meters. This is by using equation of motion. Then if we are to use velocity time graph, we know that the vertical axis is velocity, the horizontal axis is equals to time. We have the initial velocity here, u is equals to 0, and the final velocity is not given, so we assume here to be final velocity, which is plotted against time. T is equals to 30. Let's say 30. Here is 30. We now have to trace and draw from the point of intersection to the initial. So here is our velocity time graph. And we know that from the slope, acceleration is equal to the slope. which is acceleration, is equal to change in v over time. And the final velocity minus initial, we now have v minus 0 over the time, which is 30. Now have 30. So we know that acceleration is 2.5. 2.5 is equals to v over 30. Therefore, v is equals to 2.5 times 30. We have 75 meters per second. From here now, we can find our distance, which is area under the graph. And area under the graph is given by, if you look at the graph, it's a rectangle triangle. We now have 1 all over 2 times the breadth times the height, which is the breadth 30 minus 0. We now have 1 all over 2 times 30. Then the final velocity minus 0, which is the height, we now have times 75. Therefore, 2 here we have 1, 2 here we have 15. Therefore, distance is equal to 15 times 75. We have 1,125 meters. And this is in one of using velocity time graph. Question 2. A body moving with an initial velocity of 30 meters per second accelerates uniformly at a rate of 10 meters per second square until it attains a velocity of 50 meters per second. What is the distance covered during this period? Using the equation of motion, let's first of all bring out the given. We have initial velocity u is equals to 30 meters per second. We have acceleration, uniform acceleration as 10 meters per second square. And we have the final velocity as 50 meters per second. What is the distance covered during this period? We are asked to find s, which is the distance. And from the 4 equation of motion, we have v is equals to u plus at. We have s is equals to u plus v over 2 all times time. We have s is equals to ut plus half a t square. And we have v square is equals to u square plus 2as. If you look at this parameter now and compare it with the 4 equations, you will see that we have 4 parameters. We have 3 parameters to find the 4th one. We have initial, acceleration, and final velocity. When you compare the two, here there is no distance. You cannot use that equation. If you look at this, there is no acceleration. You cannot use that equation. When you look at this, there is acceleration, there is initial velocity, but there is no time. You cannot use that equation. Then if you look at the 4th equation, you have the initial, the final velocity, the initial velocity, and acceleration, and we are asked to find s. So this is the best equation we can use to calculate for this question. So from there now, the equation will now be v squared is equals to u squared plus 2as. I'll know that v squared is equals to 50. Now 50 squared is equals to the u squared, which is 30 squared plus 2 times the acceleration, which is 10, times the s. That is what we are looking for. 50 squared will now be 2500 is equals to 30 squared will now be 900 plus 2 times 10 will now have 20s times s. When you move this 900 to this side, it becomes 20s is equals to 500 minus 900, which is equals to 1600. Therefore, distance will now be 1600 divided by 20. This here, 0 cancel 0, become 160/2. 16 divided by 2, we have 80. Therefore, we now have 80 meter. This is one of using equation of motion. Let's solve it with velocity time graph. Know that the vertical line is the velocity, the horizontal is the time, and the initial velocity is 30. There's 0. Let's assume here to be 30 meter per second, and final velocity is equal to 50. Let's assume here to be 50 meter per second to time t. Then when you draw here to the initial, this is our velocity time graph. And we know that in velocity time graph, the slope is equal to acceleration. Let's find the time using the slope. Now have acceleration is equal to change in v over time, which is 50 minus 30 over the time. I will know that acceleration is equal to 10. Now be 10 is equal to 50 minus 30, which is 20 all over 10. Therefore, time will now be cross multiply, now be 20 divided by 10, which is 2 seconds. From here now, we have time is equal to 2. We can solve it using the area under the graph, which is the distance. I know that this shape of this area under the graph is a trapezium. Sum of parallel times the height. We now have S is equal to 1 all over 2 sum of parallel times height, which is 1 all over 2. From here to here is 30 times bracket 30 plus from here to here is 50 times the time from here to here, which is 2 times 2. This cancel this. Therefore, S is equal to 30 plus 50 becomes 80 meter. This is the one of using velocity diagram. Let's go to question 3. Question 3. A bus moves from rest with a uniform acceleration of 2 meters per second square for the first 10 seconds. It then accelerates at a uniform rate of 1 meter per second square for another 50 seconds. It continues at a constant speed for 70 seconds and finally comes to rest in 20 seconds by uniform deceleration. Draw the velocity time graph of the motion using the information given above. From your graph, or otherwise, calculate the total distance covered, the average speed for the whole journey, and the average retardation of the body if brought to rest. From the question, let's draw the velocity time graph. We know that the vertical axis is the velocity and the horizontal axis as time. So that a bus moves from rest, which is from U0. It moves from rest with a uniform acceleration. I know that uniform acceleration is an increase in velocity. So here's the increase for 10 seconds. 10 seconds. Let's assume here to be final velocity of this first movement, which is v1. It then accelerates at a uniform rate of 1 meter per second for another 50 seconds. Let's say accelerate again, which is an increase in velocity, as for 50 seconds. You add that 50 seconds to this, you add the 10 to the 50 seconds, becomes 25 seconds. Let's assume here to be v2. It continues at a constant speed for 10 seconds. Constant speed also means constant velocity or uniform velocity, where the slope is a straight line. So, constant speed for 70 seconds, let's assume here, 70 plus 25, we now have 95. And finally come to rest in 20 seconds. Finally, it comes to rest, that is, it returns to the horizontal line, which is equals to, in return to the horizontal line in 20 seconds. 20 plus 95, we now have 115 seconds. We are asked to calculate the total. We are asked to calculate the total distance. We are also asked to calculate the average speed, and we are asked to calculate again the average retardation. But for us to calculate this total distance, we have to find velocity 1 and velocity 2. And for us to find velocity 1, we have to consider this first slope, where acceleration is equals to 2 meters per second. From here now, we can see that acceleration, which is the slope, is equals to the v1 minus 0, now be v1 minus 0 over 10 minus 0, which is 10. When you cross multiply, you now have v1 is equals to 10 times a. And acceleration is given as 2. Therefore, now become 10 times 2, which is equals to 20 meters per second. For us to find our v2, we make use of this second uniform acceleration. Let's say here is a2, which is equals to 1 meter per second square. When you consider this slope, we now have a2 is equals to v2 minus v1 over 25 minus 10, which is 25 minus 10, which is equals to v2 minus v1 over this minus this, we have 15. So when you cross multiply, v2 minus v1 is equals to a2 times 15, which is 15 times a2. And we know that a2 is equals to 1. Therefore, and v1 is equals to 20. Now the v2 minus 20 is equals to 15 times 1, which is 15. Throw this 20 to the other side, become positive. Now the v2 is equals to 15 plus 20. We have 35 meters per second square. and this is our V2. Now, we'll consider distance, this first motion, the second motion, the third motion, and the fourth motion. Let's see for the first motion is S1, S2 for the second one, S3 for the third one, and S4 for the fourth one. If we are to consider this area under this graph, we know that this is a rectangle triangle. S1 will now be equals to 1 all over 2 times breadth times height, which is equals to 1 all over 2 times this minus this, which is 10 for the breadth, times V1 minus 0 for the height, which is 20. Now the year 1, here will come 10. Therefore, 10 times 10 is equals to 100 meter. If we are to consider the graph under this area, and when you look at this graph, the area is a trapezium, and trapezium is the sum of the parallel times the height. So it now be S2 is equals to 1 all over 2 bracket sum of parallel times height, which is equals to 1 all over 2 bracket from here to here is 20 plus from here to here is 35, which is 35 times the height, which is 25 minus 10 is 15. We now have this plus this becomes 55. That is equals to 1 all over 2 times 55 times 15. We have 412.5 meter. We'll also find S3. We consider the area under this graph. And we know it's a rectangle. And the formula for rectangle is length times breadth. Therefore, S3 is equals to length times breadth, which is equals to this minus this is 70 times this minus this, which is 35. We now have 2450 meter. Therefore, S4 will now be 1 all over 2 times breadth times height, which is 1 all over 2 times this 115 minus 95, we have 20, times the height, which is 35. This counts 2 go here, we have 10, 2 go here, we have 1. That is this, we have 350 meter. For us to find the total distance traveled by the bus, it now be ST, which is S1 plus S2 plus S3 plus S4. Total distance traveled, which is total distance traveled now be S1 plus S2 plus S3 plus S4, which is equals to S1 is 100 plus S2 is 412.5 plus S3, which is 2450 plus S4, which is 350. When you add it together, S total will now be 312.5 meter, which can be approximately to 3.3125 kilometer. Find average velocity. Average velocity is the total distance traveled per unit time. We have average velocity is equals to the total distance traveled over time, which is equals to total distance traveled is 3312.5. 3312.5. And the total time taken is 115 over 115. When you use this to divide this, average velocity now be 28.8 meter per second. And the last question, which is average retardation. Average retardation is equal to the slope of this decrease in velocity, which is change in v2 over v0 over change in time. We now have average retardation is equals to change in velocity over change in time. Change in velocity is equals to the v2 minus v0. v2 minus v0 over 15 minus 95. 115 minus 95. We now have v2 is 35. We have 35 over 115 minus 95, we have 20. Therefore, average retardation will now be 35 divided by 20 will now be 1.75 meter per second squared. And this will be the end of uniformly accelerated motion. Our next video will be motion under gravity. Please click on the subscription button.